The best way to find great stocks is understanding a company's products, not just their profits. Huge growth happens when a company has the perfect product for a high growth market, like generative AI. I recently came back from GTC, NVIDIA's huge developer conference showcasing the latest innovations in AI, and I got an exclusive inside look at some of NVIDIA's next generation products making these innovations possible. I'm joined by Charlie Boyle, Vice President of DGX Systems at NVIDIA, who's deployed the hardware and software powering the biggest AI models on Earth. And he shared some big insights about data centers, the AI power problem, and where the industry is headed next. This kind of boots-on-the-ground research is so valuable for understanding the science behind the stocks. And your time is valuable, so let's get right into it.
Charlie, it's great to meet you.
Great to meet you.
One of the first things I got to ask you actually is, I think this is the 9-year anniversary of DGX, and so much has changed over the last 9 years. I'd love to know how DGX started and how it's evolved through the years.
Yeah, you're absolutely right. It was 9 years in this building in San Jose. DGX won behind velvet ropes. Jensen announced it to the world, and a lot of people said, "Oh, NVIDIA is building a server." We said, no, that's not right. We're building an AI system, because DGX isn't just the best server hardware that you can get, the best system hardware. It's a full software stack associated with it. So DGX had one goal 9 years ago, and it still is the same goal today, is to deliver a complete AI system to our end users so they can get up and running with their models and their training. Now, a lot has changed in 9 years. The systems have gotten bigger, the models have gotten more advanced, and more importantly, people have gone from just building foundation models to actually running those foundation models for real-time AI.
So walk us through, what does a typical DGX system look like today? What are we looking at right here?
Right, so here we have our DGX B300 design. This is what most customers would have been deploying, whether they're deploying DGX systems or our great partner systems. This is an HGX 8-way NVLink system. Okay. What's different, if you've seen all of our other designs, the entire panel on the front of every other DGX has been this beautiful gold metal foam, and you see something that looks a little different on the bottom. There's ports and there's other things at the bottom now. Yeah. We actually did a design change in this generation DGX to make it more efficient and hyperscale friendly, to bring that hyperscaler efficiency into every enterprise, no matter where you are in the world. So this is now front cabled, easily accessible. You do all the serviceability in the cold aisle. So whenever you do have to service a system, everything pulls out of the front. And if you've ever been in a data center, there's the cold side and the hot side of the rack. Yeah. And it's so much easier if you have to work on the cold side of this. So we've minimized anything behind the servers so that almost everything that you have to ever do on the system for maintenance is in the front of the system.
I'd actually like to pick your brain on that a little bit. So I've spent a lot of time talking to people about the B300 side of things, right? Yeah. The compute, the CPUs, the GPUs, the scaling up and scaling out. But as you scale up and scale out, resource management becomes such an important issue, and managing your total compute. Can you talk to us a little about the innovations that have happened on that side of things?
Yeah, as we've grown up from 9 years, people started out buying ones and twos of these types of systems. People are now buying thousands at a time. And when you're dealing with systems at that scale, a lot of things matter in terms of the complexity of your data center. We have a general design that we call the DGX SuperPod, and that's what most of our customers buy. That's a defined architecture stamp of a set number of systems, networking, storage, all put together so that it's replicable all over the world. And one of the great things that we've done in the DGX platform that our customers really appreciate, we build exactly one version per generation. And what that does, some people say, well, people want options and everything. All of our great OEM and ODM partners build systems in any option level you want. Every single DGX system that a customer's ever bought in a generation is identical around the world, and it's identical to what we run inside of NVIDIA. So as we get optimizations, things that we learn, to help our own internal people, we push all that to our DGX customer base, so they're getting the best use of the systems, and we continue to innovate on the systems. I run a DGX user group every year here at GTC. We did it yesterday, and we talk to our customers, we get survey results from them, like what are they doing? We see the evolution of how they run workloads, but we also see the evolution of what they value and what they need from us. And one of the biggest things they tell us they need from us and that they use is our software stack and our NVIDIA containerized applications. Yeah. So as you want to get the latest model, you don't want to do all the work compiling it, making that ready. Every time a new model comes out, usually within 24 hours, there's an NVIDIA containerized version that every customer, whether you're a DGX or not, but especially our DGX customers, can get that model. It's built. We do all of our internal development on DGX, so the next day they have access to that model, they can try it, and they know it's tested and it runs really well.
One of the things that I always hear when I come to these conferences is the new bottleneck is power. So one of the big things that I know that has evolved over the years is the way the DGX system can manage power.
Yeah, and maybe we could walk around the back of the rack here to show you something we did special this time. Our HGX systems that are the industry standard. If you go to any CSP, any OEM, and you buy a GPU server or GPU instance, that's our HGX system. We've had that for the past 5-6 years, and so the millions of systems deployed are all HGX. We'll talk about our new GB systems in a little while. Sure. But as we saw our customers expand and not just buying hundreds but thousands of systems, that how can we make sure that they don't have any wasted power? That's something Jensen talks to us about internally, because we run thousands of these things ourselves. Yeah. And he talked about in the keynote, power is the new currency.
Every single data center in the future will be power limited. Your revenues are power limited. You can figure out what your revenues are going to be based on the power you have to work with.
Yeah. It's not data center space. I can find land in a lot of places. Finding power is more difficult. And what's happened in the past, and this is a general computer, industry issue, you always had to provision for peak power because you've got a steady running state, but at certain points in very small time scales, the computer needs a lot of power really quickly and then it goes back down.
Which means you've provisioned for a lot more power than you're normally actually using, right?
Correct. And most people today aren't building their own data centers. They're going to other data center providers. And when you go to those providers to get power for your cluster, your AI deployment, whatever you ask them for, they will give you for, but you're charged for it. So if you ask for a megawatt of power because that's what you need for peak, you're paying for the megawatt whether you use it or not. Yeah. And so one of the innovative things that we did in the B300 series that we learned from our GB series is how do we smooth that power peak out for customers. And so what you're seeing here is it's the same DGX B300 system, but with two different power configurations. This system looks like what you're used to in the data center. You've got a lot of small power supplies that plugs into your rack level PDU. That's how everyone deploys systems today. In the system on this side, we have a rack level bus bar. So the same high power, high capacity data center level power shelves that we started using in our GB systems, we now have in the DGX B300 systems. Literally the systems slide into the rack, there's the bus bar, and that's all of its power. So the system that has the bus bar actually uses a little less power to deliver the same performance because I've got that highly efficient data center level power shelf in the rack. But both systems, what we did in this generation, we added energy storage to the power supply. So even these power supplies and the data center power supplies, that energy storage, we generally think of capacitors, allows you to smooth out that peak. So whatever the kilowatt rating is on the system is all you need to provision for. So you get to use your systems at 100%, full throughput without having to over provision power. That saves customers so much money, but more importantly, as Jensen talked in the keynote, when you save power, then I can run more systems, I can run more GPUs and get more work done. And in the inference workload side, I can make more money because I'm generating more tokens.
That's right. No, that makes a lot of sense. So those are just some of the hardware innovations though, right? Walk me through some of the other innovations in power and resource management that we've gone through.
Yeah, so let's go look at the GB series systems so we can talk about how that comes together at our highest ends.
Let's do it.
So these are our new DGX GB300 systems. It's right next to the system we launched last year, the GB200. Yeah. And when you look at these systems, they look identical from the outside. It takes a keen eye to see this one has a couple less ports on it because in the GB300 series, we introduced the new CX8 networking technology, doubling the network speed and bringing new flexibility to the system because the ConnectX8, which we call the CX8, is a super NIC. And so the super NIC can do both Ethernet and InfiniBand, either one just as a software setting. So, when we build these systems for our AI factory, we can deploy them And at the time of deployment, the customer can choose, do they want Ethernet? If they're an all Ethernet shop, they've done it for 20, 30 years. Jensen talked about this in the keynote. Well, we've got Spectrum X. If you're used to InfiniBand and you want the highest level, lowest latency interconnect, you can use InfiniBand, but we didn't have to build two different systems. So the systems look virtually identical. Of course, the GB300 system has our new Blackwell Ultra chip in it.
Yeah.
But when you look at these systems, and I said we've got these running in our data center, a whole super pod of these down in South San Jose that's actually running the live show floor demos, which is super cool, that people are now using these things for production inference. DGX used to just be training. Everyone built foundation models. Our customers did great work. But when you look at a system this big, you go, oh, that's got to be for training. Look at how massive it is. But no, as Jensen talked about real-time inference, these massive models, you need something like this to get the latency down. But as you look at something like this looks like a computer that you've never seen before.
Yeah.
As most people think about, how am I going to run AI, it's daunting to just think about a regular GPU server. And if I've never used that in my enterprise, like, how am I going to do that? And you look at something like this, and it looks like a spaceship. Like, how am I ever going to make that work?
Yeah.
And so part of the DGX platform over the years has been that complete AI system. It's software and hardware all working together. And so we've done a number of things in this generation with a new software package called Mission Control to actually make all this work a lot easier.
Walk me through some of the innovations that come with Mission Control. How is the user flow today, and what does Mission Control turn that user flow into?
Right. So this software stack, like most things that we do in DGX, all originated from what we do inside of NVIDIA.
Yeah.
That's a lot of our core founding principles of DGX is take the great work that we do inside, all of our leading edge research, and deliver that to customers in an easy to use way. As you know, if you worked in any tech company, internally developed software doesn't always translate to end user software, because of course it's your own engineers building it. And so what we've done in Mission Control is take the entire life cycle of an AI factory and codify it in software. So the first thing you do is when you put your AI factory in your data center, well, you've got to provision it. I've got to test all the computers, all those things. We call that commissioning. And when I've done that, there's a ton of automation that you have to put into it, because I want to check all my cables are correct. The SuperPod I talked about in our data center down the street, one SuperPod, 8 racks of this, has 22 kilometers of optical cabling in it.
Oh my gosh.
And you think of, even the old Chevy Chase movie when he's plugging in Christmas lights, he gets one thing wrong, Christmas lights don't work.
Yeah,
if I've got 22 kilometers of cable, there's, a huge potential, even though we've got fabulous professionals, plugging everything in. You want those automated tests to make sure that every cable is plugged into the right port, doing the right thing at 100% bandwidth. So once I've got the system commissioned, then I want to configure it for how I'm going to use it. Am I going to use it for inference? Am I going to use it for training? So we have automation in one of our tools that we call Base Command Manager. That's kind of your data center view of these systems, and that helps you see all of your infrastructure, how I'm deploying it, what type of applications am I running on it, and what workload management do I want to run on top of it. We recently acquired Run.ai, and that's the way a lot of our application users get into these systems, and really provides them, on some stats that we've seen, from Run.ai, customers are getting a 5x improvement in GPU utilization just because they're able to pack work into, all the GPUs that
more
they're running.
efficiently manage and schedule their workloads, and
Yeah. And so when we think about those things, we have two user personas. I've got the data center team that is running the systems, making sure power, electricity, firmware, software, everything's up to date. So the automation that we put in Base Command Manager does all that for you. When we give you a quarterly update for your SuperPod, I can deploy that entire update automatically through Base Command Manager, and that type of update could touch everything from firmware, from NICs to operating systems to patches. That entirely, very complex update stack, you want orchestrated, you want tested. We test this in all of our systems internally before a customer ever sees it. But more importantly, the end user that's actually running work, your AI researcher, your data scientist, they just want to get work done. Like, they don't want to have to think about well, how hot is the server running? What's my pump speed? That's I want to run a job on 500 GPUs. I want to have 1,000 inference servers. Just do that work. And that's our AI user interface through Run.ai. You can just say, here's my data, here's how many GPUs I want to run, push a button and go. which there's been a lot of scheduling technologies that have done that in the past, but what we've done in NVIDIA Mission Control is once the job is running, once the service is running, we're automatically making sure it stays up and running.
Right.
If a large parallel processing, batch type of job, if something happens to that, well, what happens? The whole job stops.
Yeah.
Well, if you're not watching it, and that stops right after you leave the office, and you don't see it till you get in the morning, you've lost 8 hours.
Right.
You don't want that. And so what we've done all the way from the top of the software stack in the application framework, doing in-memory checkpointing, automatically checkpointing asynchronously super fast to memory, keep the job running, and then in the background write it to disk. If I do have a problem, the system notices the job stopped, automatically goes back to the checkpoint, restarts it. So maybe I lose a minute, but I don't lose 8 hours.
Yeah, right.
And that's really the biggest thing in AI. I want to keep making forward progress. Now, massive companies, we saw this in the report from OpenAI when they trained the original ChatGPT, they said they've got a 24/7 staff that just watches jobs. Well, what enterprise can have a 24/7 staff watching their jobs? Even if you had enough money to pay them, you couldn't attract that. So we've done all of that in automation to make sure your jobs keep running, to minimize downtime.
That's smart, yeah.
And when something does happen, if I need to reallocate resource, maybe I do have a hardware problem. Well, this Mission Control automatically reallocates hardware either in the same rack, finds a different rack to keep the job at the priority you have running smoothly. So as we think about AI factories, and of course Jensen's been talking about that for a number of years,
Yeah.
like a lot of customers, they don't know how to build a factory. Of course, we have great manufacturing customers, and when they think of a factory, it's like, well, I'm going to build a factory, it's going to sit there for 100 years.
Yeah.
And just like we think of auto manufacturing, the same building has been in production for 100 years, but 100 years ago, did they have a laser welding robot? Of course not. You
Right.
always are upgrading your factory. And so we want to make it easy to install and upgrade AI factories for our customers, no matter what generation they're in. As Jensen talked about in the roadmap, we're having major roadmap innovations every year.
Yeah.
So where in the IT industry do you take yearly updates of major infrastructure?
Yeah.
Before NVIDIA, I worked at Oracle. For systems like the Oracle database, people upgrade those every 5 years. Like if you're in banking, it's every 10 or 15 years.
Yeah.
But we're talking about major innovations every year. So one of the great things at NVIDIA, and this started 30 years ago, we have a single unified architecture. So as I talked to in the beginning of this, when we talked about DGX-1 launching 9 years ago, the same software that ran on that DGX-1 9 years ago, that same application that you wrote 9 years ago, will run on one of these systems today because it's always backwards compatible. And so what makes that great on a roadmap perspective, and what I tell customers every day when they say, well, Charlie, GB200 is shipping today, should I wait for GB300? I said, do you need AI today? If you need AI today, buy the GB200.
Right.
When this comes out, you just add it to your AI factory because it's a single software stack running everything.
Right.
But as you think about that AI factory, as I said, this is a whole different animal. So we've actually partnered, for the past 5 years with data center providers all over the world to get them ready to run these style of systems. As I mentioned, the SuperPod that we're running just a few miles away from here, it's actually an Equinix data center. And we worked with them, we worked with all of our data center partners a couple of years ago to get them ready for this style of computing. This is a 120 kilowatt rack. And, when enterprises are like at 10, 12 kilowatts, this is a lot different.
Yeah.
And so we've gotten those data center providers ready that you can just call up and say, I want this size DGX SuperPod. And they say, great, we've got facilities, we've got everything, and they know how to install and run these things. So as a customer, you don't have to say, well, now I've got to go get a plumbing contractor, an electrical contractor, everything else. No, all of our data center partners have that. They have our blueprint, and so that it gets stamped out the same way every time. And as an example, when we deployed our own systems, we built the shell of the data center, all the liquid cooling, all the cabling ahead of time, because these systems were just coming off the production line. We literally rolled the racks in, our cabling team plugged them in, and from the time it hit the elevator in the data center to the time that our engineers were using the systems was under 24 hours.
Wow.
So getting something this complicated up and running, fully commissioned in under 24 hours, is just amazing. But the only way we do that is by working ahead of time with the data center providers, having a standard deployment, that's the DGX SuperPod, and then being consistent over time no matter where you are in the world.
Yeah, and that makes a lot of sense because I know some of the jumps between generations have huge implications, right? For example, moving to the Blackwell architecture comes with liquid cooling instead of air cooling. So there are massive implications in that yearly upgrade cycle.
Right, and that's why we want to minimize that to customers. And even inside of Mission Control, it has liquid cooling management in there, because when you're dealing with liquid cooling versus air cooling, the entire data center is just cool.
Yeah.
And as part of that, as an end user, you're like, well, as long as my system is at the right temperature, I'm fine.
Yeah.
But with liquid cooling, if I'm going from idle to 100% power, well, I've got to go signal the pumps to turn on. When my job is done, I've got to signal it to turn down. And as a user, would anyone know how to set the right knob on pump speed? No, even as a data center operator, you don't need to do that. So a data center partner like Vertiv, who does the cooling distribution, a CDU, is integrated with NVIDIA Mission Control. So when you start that job, as the job starts the preamble of setting up all the servers, setting up all your work stream, it's also talking to the CDU and saying, get ready, start spinning up the pumps. Yeah. And when the job is starting to run down, we do the same thing. That's all automatic. And it's things like that you don't think about until you need it. And so we've had to do that because we build these internally for our own use, and we take that knowledge and give that to our customers. So it's not the 11th hour and they're like, oh my God, I need a liquid control system. That already comes with the system because we thought about it, we delivered it as part of the package.
So it's probably useful to think of mission control as a true, almost a literal spaceship, where it's like the pre-flight checks, all of the system checks, hardware, firmware, software, version control, cross communications control. It's literally that whole stack of understanding what's going on in your system at every level.
Yeah, and part of the reason we named it that, we're all space fans around
absolutely.
here, and I grew up with NASA and everything. And when you looked at launch control, there was, back in the day, hundreds of monitors. And before you launched, you checked in with everyone. Are you good? They said go. Everyone said go. Until you finally got to the flight director, and they said, everyone said go, so I'm a go to launch. Yeah. And that's the concept of this. No matter what the complexity is, no matter what the generation from B300 to GB300 to the new Vera Rubin that Jensen announced is going to be coming, all that automation is built in, all that knowledge is built in, and as we get more knowledge, that gets delivered as a stream, as a rule set directly to customers as often as they want it. You can get it real time, you can get it every day, you get it every week, however you want that. But the thing that our engineer just learned, over in Taiwan is available to customers real time the next day.
That's huge. That's huge. So we're standing in front of the DGX for the GB300, right? Yep. Is there anything else you want to tell me about Vera Rubin?
Yeah, we can come look at the concept design for Vera Rubin over here, because Jensen talked about it in the keynote.
Yep. Which means I get to ask about it.
Yes. Yeah. It's a beautiful design. Is one of the big things that we do every generation is not only make it work but make it beautiful. Yeah. And we constantly, from when we originally launched DGX, we had the beautiful gold bezel. Everyone's like, do you really need that? What does it do? And as we've gone through the years, and people say, well, why do you still focus that much on industrial design? The GB200, 300 systems have 600,000 components in them. The mechanicals are extremely complex because there's thousands of pins on the back of the backplane that you've got to plug into. If I'm doing that level of industrial engineering, I might as well take the extra step to make it beautiful. Because quality and craft is so important, because you've got one pin out of 5,000 off, the system doesn't work. And so as I have to pull these systems in and out, these are all liquid cooled, I've got drip-free blind mate interconnects right next to my signaling, right next to my power, doing all that at an industrial level. So design matters, industrial design matters, mechanical engineering
User experience matters too.
Of course, if you're running a system like this, of course these are high value systems. We want to make sure it's up and running. We want to deliver that to the customer. And you think about, what Jensen talked about, 600 kilowatts. I've had a lot of questions this week on, well, who even has that?
Right, yeah.
And that's part of why we work with our ecosystem so intently. And just yesterday, we do this every year at GTC. We had over 100 people from the mechanical and electrical ecosystem, names that that you walk down any data center rack. They were all at the NVIDIA headquarters, where we were giving them specifics on this. So when this system comes out in a couple of years, we're ready for it. The industry's ready for it. And it's not just NVIDIA telling them here's what we need. Of course, we give them our specifications, but we work back and forth how are you going to deliver 600 kilowatts in this form factor? Right. How are you going to get enough liquid in? And we work engineer to engineer back and forth so that when this is coming off our factory line, they've got all the data center equipment lined up. And some of the interesting things that we did in this platform concept, you could see this side of the rack, you could see the back side of the rack. It's identical because there's actually a center mid plane where all the systems plug in.
Okay.
This, what looks like a chassis here, that's 72 GPUs right there. So that 72 GPUs is the same 72 GPU capacity as the much bigger thing in the GB200.
So that's actually like this one block is a whole rack over there.
Right.
Yeah.
And so we've compressed all of that down. This is 100% liquid cooled. So if you pull out a board, you'd see everything on it is liquid cooled. One of the challenges in that is I could just put a giant piece of copper on top of the whole board and have one cold plate, but I still need to make it serviceable. There's tens of thousands of components on there, so it's not about just cooling, because I can cool it, but how do I cool it and make it serviceable in the data center? So this is our Vera Rubin design concept for our densest system, Vera Rubin Ultra. And of course, there'll be other generations. You'll hear more about that at future GTCs, but this is what's possible, but it's only possible by engineers working together and software being able to control this, because no human could touch the millions of parts in here and make it all work at any one given time. You need software, you need automation, and you need knowledge to make it work.
That's crazy. I would have never thought of any of that, right? We talk so much about the increase in compute performance, the increase in compute density, scaling up and scaling out, but how do you actually manage the system complexity as it grows and grows by orders of magnitude seemingly every 2 or 3 years? I mean, this is incredible.
We have tremendous customer speakers telling us about how they're using their systems, what they're doing, from advances in medical, to serving user populations in sovereign AI. And the great thing that I hear from my customers, as I talk to them around the show, so many people come up to me and they said, hey, I remember when I got my first DGX1, and now they're telling me they can't wait to get their GB200 system. And they've had every generation, they've been able to adopt it, and it just gets better every year. And they just count on us hey, I know NVIDIA is going to have something new every year. I need to plan for that. I've got to put it in my data center plan. And that's why Jensen always talks about the roadmap now, so we don't surprise anyone. We're ready to meet them when they're ready to intercept our roadmap.
DGX seems so instrumental to keeping that pace and keeping everyone on the same page. I always ask this question to everyone I interview. It's the 9-year anniversary of DGX today, which means 10 years, only 1 year out, right? Yeah. What excites you about 1 year from now? Is there something big you're looking forward to in the year ahead, a big impact of this system?
I think the biggest impact is the transformation that people are having on running AI applications in production. That's been the big change. We heard about the reasoning models, all those things, the explosion in AI. What I hear from customers consistently every time we do one of these shows, we did an AI summit in DC last year, a lot of customers talked about, I built an internal application, I built a customer application, I did a little beta test of it, I had 50 users on it, they all loved it, and as soon as I turned it live, I had thousands of users. I had a big government contractor customer that said, as soon as they turned it live, 70% of the company used it the first week. And so a big theme that we see is AI scaling. We build that into software so that you're ready for success, and that's part of the AI factory concept is, I need more capacity, I just add more capacity. I don't need to re-architect things, it's all built in. So what I'm really looking forward to next year is, we just launched the Blackwell Ultra Series this year, all the great customer stories we're going to see next year of what people did with it, because they always surprise me on I didn't think that was a possibility. I didn't think you could, save people's lives, with this type of, technology, roll out new services that are impacting every citizen in your country. So, it's those customer stories that really make it special every year.
Those are massive scales. Charlie Boyle, thank you so much for your time. This was awesome.
A huge thank you to Charlie Boyle for walking us through NVIDIA's DGX hardware ecosystem, the challenges that data centers face when it comes to managing power, heat, and large AI workloads, and all the automations and innovations going into managing them at scale. I think this kind of boots-on-the-ground research is so valuable for understanding the science behind the stocks. Another big thank you to NVIDIA for inviting me to GTC again this year, and thank you for watching to the end and supporting the channel. Until next time, this is ticker symbol U. My name is Alex, reminding you that the best investment you can make is in you.